In this recording, we're going to learn how to solve rational equations and rational inequalities. And we're going to solve them algebraically if possible, and then check graphically and also check numerically on our table to make sure our solutions make sense. So I'll give you a chance to write this one down. When you're ready, play the recording. Okay, so again, we're going to try to solve it by algebra. So we don't like the fact that we have an x in the denominator, that division. So we're going to multiply all terms by that LCD there. What that does is it divides out our x in the denominator. So we have simply an x squared plus 3 equals 4x. Go ahead and solve that. Play the recording when you're ready. Okay, so hopefully you got all the terms on one side because you have a quadratic. And you factored and solved. Okay, so we think those are our solutions. Let's box them in. We can verify this graphically. We can also look at our table. So let's check the graphical check. So we'll go to our graphing calculator. We're going to enter that original expression, but with the 4 subtracted. So we've got x Okay, so I've basically taken the 4 that the equation was equal to and subtracted from both sides. Now let's check out a graph. We'll zoom 6 just to see how things look out. Okay, cool. So I can see both of the intercepts there. Go ahead and take a screenshot of that. Okay, so what we'll put into our notes. Okay, so once you've got your axes set up, which is a little bit tedious, we have a vertical asymptote right on the x-axis. No surprise, right? Because that's where x equals 0. And we are looking at x-intercepts right there. So it dips right below the x-axis there. It looks like a slant asymptote, something like that. And then down here, we have another portion of the graph. So sort of continuing down, and it kind of comes up and then back down along the asymptote there. So we have those 2 x-intercepts there. That all makes sense. And then finally we can check the table. That's our numeric check. So we're anticipating on our table to a couple places where the y values are 0. And those x values that correspond to those y values are in fact 1 and 3. So let's just make a note of those in our notes here. A note in our notes. Okay, again, circle those. Those are the solutions to that equation. Okay, so the other thing I'd like to work on is solving rational inequalities. We're going to find the solution sets algebraically and then confirm that graphically. All right, so I'll give you a second to write this question down. We're going to solve it out algebraically. Okay, so where are the natural breakpoints in this graph? So let's consider that. Okay, so something will change with respect to its positivity or negativity, right? This is what this is basically saying is, where is this equal to 0 and where is it greater than 0? So probably at the x-intercepts and possibly at the vertical asymptotes, because at the vertical asymptote, sometimes you have parts of the graph that go towards positive infinity and some go towards negative infinity. So let's first consider our vertical asymptotes. So that's our vertical asymptote. We're also going to consider get another color here. We're going to consider the x-intercepts. So that's where the numerator equals 0. I want to be consistent here, how that I write an x-intercept as a point and a vertical asymptote as a line. Okay, so we think something's happening at those 2 points. Let's see if in fact that's the case by checking out our graph. So in the graph, we'll just enter that fraction. And we'll look at the graph of that function. Okay, so let's say what we're going to do, and let's sketch that out. We're going to do a graphical look at it. So having entered that into y1, we can make our sketch. We have a horizontal asymptote at y equals 1. No surprise, right? Because that's the quotient of the leading coefficients, given that the degrees were equal. Okay, so we've set up our axes. We do have a vertical asymptote at -3. Now we can just show our sketch. Okay, that portion of the graph is bound by those 2 asymptotes. And then the other portion does have an x-intercept at 1. Okay, so finally, what are the points? Where is the portion of the graph that is greater than or equal to 0? Well, let's kind of create some space down here. So it is certainly greater than or equal to 0 for all these points to the left of x equals -3, right? So if I were to write this in interval notation, in set builder notation, x such that x is less than -3, all those points right up to -3. And then once we get to 1 and go bigger, including 1, those all satisfy the inequality as well. So that's called set builder notation. We can also express it in interval notation. So interval notation says, okay, you're going to start down here at -infinity, and you're going to keep going right up to the point where you get to x equals -3. But not including -3, right? Because that's on the asymptote. And then it does not, y is not greater than or equal to 0 up until the point where it gets to there. And then it starts over. So union, and it's a square bracket, 1, and then it continues to be greater than 0 all the way towards infinity. Parenthesis. So either one of those forms. Or you may write it in interval notation. Thanks for watching.